Hello, Naveen. Hello.
Sorry for that, Aniket. I was on mute.
Yeah. So Naveen, before starting today's session, can you just list down in chat what all topics have been covered till now, and like what are we planning for further sessions?
Oh, okay.
Yeah.
You need it right now,
In the
Aniket.
chat. Yeah. In the chat.
Okay. One moment, please. Send it to you directly. Would you like me to send it to you directly?
You can share with everyone as well. Like not an issue.
Okay. Well, just give me one moment, Aniket. I'm just typing. So, okay. It's sending it right. So, here we go. A slightly high level. I didn't go into the low level details. Aniket.
Yeah. DevOps is not included in any one of it.
Docker.
The AWS DevOps.
That is what is the Docker, Kubernetes, and Jenkins is.
Actually, the DevOps which we were looking now, that was slightly different because it was listed to have Sonar Cube, then Nexus, everything in place.
That
Like
will-
an end-to-end CI/CD solution we were expecting. So that was the one case. And in Ansible also, like playbooks, like playing around with playbooks. This is what we were looking for because we are going to use Ansible for hardening purpose.
Yeah.
Okay. That is a thing which is in topics covered. To be covered in, it's okay. Yeah, CLK, GCP infra, OpenStack. Yeah, that is okay. But the topics which you have covered now,
Yeah.
there's slight little other expectations from what you have covered, because in scripting as well we have
Yeah.
done right, but we were expecting lambda level scripting, means the scripting we do in AWS lambda.
Okay. Okay.
The scripting expected. Ansible, I told you, hardening purpose.
Yeah.
And Docker you have included DevOps. So DevOps, as it was mentioned in the sheet, like we were expecting two scenarios.
Okay.
One was using Jenkins, SonarQube, and code deploy of AWS. And one was using code build, code commit, and code deploy of AWS, everything of AWS. And one was using Jenkins, SonarQube, Nexus, and code deploy. because we were looking for an end-to-end CI/CD solution. Means if any of the scenario occurs, so we should be in the place to do that CI/CD pipeline. So that was the expectation actually.
Let me just make a note of it. In DevOps, you said using Jenkins and SonarQube. Huh?
Yes, yes. I'll just quickly type in the chat as well. There were two scenarios.
Okay. The SonarQube, New Relic, and all these things, I put them as part of the AIOps, ELK, and New Relic. Those are the low-level details. I put them there.
You wanted a hands-on practical on that.
Yeah. Hands-on only will do.
So for scenario is Jenkins, SonarQube, Nexus, and then using code deploy of AWS.
Have you typed them?
Yeah, John, I'm typing.
Oh, okay. Just make note of this. The first scenario is using, okay. Second scenario is using AWS code deployer. Is that what you're saying, Aniket? The second?
Yeah. Second is whole and soul of AWS, like everything on AWS, code commit, build. I don't know what is there for your test cases on AWS, but I think we can use SonarQube in between code deploy and code build, because I don't think so there's any native tool for test cases in AWS, right?
There is? One more time, please.
Yeah, I don't think so there is any, this one, a native tool in AWS for test cases.
No, I don't, for test.
So instead of using native tool for test cases, we can include SonarQube.
Okay.
Yeah. So code commit will be the committing part, building part, then SonarQube will be testing part, and then will be code deploy part.
Yeah.
We should include release in this as well, right? Because we have included Nexus in the first scenario for release management, right?
No.
Version management. Need to include this as well. Release management. And for Ansible, I'm typing for playbooks for doing scripting.
You say hardening? What do you mean by hardening?
When you do a server hardening, if it's a Windows server and there are certain parameters like this software needs to be by default installed on the server, then user cannot use this window or like that. And the user cannot do Windows R, like there are certain restrictions on the server, right? So that needs to be then port also, like port mapping, like 80 should not be used, 81 should be used. That's a basic one, like would be good for us. Definitely we will be doing R&D going ahead, but at this moment if we get a like a brief idea about how hardening using Ansible looks like by using the playbooks, then it would be great for us. Even the installation, like if it's a Grafana monitoring tool, right? So by default every server must have Grafana installed on it. So instead of doing it manually, you can create a playbook of Ansible that will install Grafana on every server.
Yeah, sounds good. What I will do is in the coming up days, I will look into these specific scenarios and I will keep adding them as we go on, because I may need a little bit of time looking into these things and actually coming up with them. In the meantime, what I will do is whatever is the other content which is there, I'll parallelly keep covering them so that we can make progress.
But Naveen, our main focus will be DevOps only, right? Like the two scenarios which you mentioned, no? We have to cover that because that is the live scenario which we are facing now, right now. So we would be needing that for the deployment purpose.
Sounds good. Sounds good.
Okay.
Thank you, Aniket.
Yeah, we can continue now.
Thank you, buddy.
Thank you.
And, let's see. So my boy Rahul, are you there, buddy?
Yes, sir.
Very good. Thank you, buddy. Give me one moment. I'm just making a note of some of these things here. Okay. So let's see. First, I will share a few of my screens, my one here, and then I will hand it over to you. Let's see this one. Using this code here, configuration files. Okay, so before I go into this one, just a few questions for you, Rahul, just to see if you're able to recall and answer any of these things. Give me one moment here, all the way up here. Okay, so what do you think is the difference between the Docker and the Kubernetes, Rahul?
Docker is a container engine. It is used to run the container, and Kubernetes is the orchestration for the containers. Like it used to manage the containers. We can manage the Docker containers using this Kubernetes.
Kubernetes is manages. Okay, good. What did you say is Docker?
Docker is the it is a container engine. Like it is used to run the container. It is kind of ship, as you told, to run the container.
In other words, to create the containers, we use Docker. Okay.
Yes. Yes.
So, if where exactly do you think the orchestration comes into the picture?
When there is hundreds of containers, it is very difficult to manage each container. So that at that time we need this Kubernetes to manage all these containers.
That is exactly what is happening. When we have hundreds and hundreds of them, we cannot manually deal with them. So that is where this comes to our rescue. Okay. And let's see, by any chance, can you tell me what kind of an architecture does Kubernetes follow?
Yeah, this is the control plane and the worker node.
Control plane and the
worker node. You can say client and server architecture. There is one.
It is the master and the server, master and
yeah.
So master is also referred as the control plane. Okay.
Yes.
What do you think the masters or the control planes main? What do you think are the main responsibilities?
It is used to manage all these worker nodes. Like if any node fails, then it will shift the load to other servers. And as there is on the screen, this is scheduling the pods on different servers and managing all the what is the state of the this Kubernetes cluster in the etcd database and all.
Very good. And let's say what else? Components. Okay. Let's see. What's the difference between container and a pod?
Containers and pods contain multiple containers, but like pod is a kind of abstraction to the container. But in one pod, there is only one container.
So in other words, more precisely, pod is an additional layer on top of a container. Yes. And you can think of it as a Kubernetes layer, and Kubernetes, all it does is it works with this layer, does not really contain as what you can think of. Okay.
Yes. Yes.
You define the service.
Service, what happens is if the pod gets destroyed, the IPs get changed. So we use the service to use the static IPs. So if the pod gets destroyed or restarted, the IP will be remain same.
Excellent. Okay, so in other words, service takes care of the can also take care of the load balancing part of it.
Yes.
Also, if the IP address part of it, and the replicas will also be taken care of the service. Service can also be said as managing a group of pods. Is
yes.
not okay. And see, what do you think is etcd?
etcd, it is used to store the current status of the cluster, like which cluster is up, which node is up, which node is down, and all the information are there in etcd. It is a database to store all the information about the cluster.
Very good. More precisely, it is a metadata. The master is saving its metadata in the etcd, which is like a key value data store or a NoSQL database. Okay.
Yes.
So I'll go while I'm going over these things. In the meantime, you can probably log into and just be ready. We'll go a few configuration files, and then we'll continue with your stuff.
Okay.
Thank you. So a little bit about the configuration files. We've already discussed about the YAML. Yet another markup language is what it refers to. On the left-hand side is what we are looking at, Nginx. Nginx is like a lightweight web server used heavily around the world for various kinds of things. From a DevOps perspective, what we can think of is Nginx is like an application which has been given to us by maybe a development team. For a DevOps team, they take this application, they will deploy it in many other ways and things like that. That is what we configure using the YAML file here. So kind of indirectly, we can use the YAML files and kind of decide the high level design or the high level architectural architecture of we can understand and design the high level architecture of the applications that are given to us is one way to think of it, guys. Okay. YAML is referred to as human friendly data serialization language. Data serialization is a lot of data is traveling around the networks. So how do you take the data and you convert it into a format and then ship it off or transport it across multiple networks is what is serialization. You're taking the data, transporting it into a network transportable format, and then once you transport it, the data is reverse engineered by the application and it does whatever it is supposed to do. So that is what is data serialization. All the programming languages have their data serialization support. And it is strict indentation. We also briefly discussed it follows some strict rules about the spacing. The same spacing, equal spacing is also what it is referred as. It stores the config file with the code generally, and with the code we can store the deployment YAMLs, pod.yamls, and other kinds of YAMLs. In a production, ideally we would have multiple masters and workers and separate virtual machines or physical machines for the nodes. Nodes can be slightly less, their specification might be less than the master. And in some cases, the nodes are also more heavily armed or more powerful than the masters based on the scenarios and things like that. In a financial world, generally, most of the time we use enterprise class servers, but in a slightly, for nodes, but in a slightly, in maybe a small startup and things like that, the nodes necessarily do not have to be enterprise class servers. They can be commodity servers. The masters are generally the enterprise class servers and things like that. So is one way to think of it. Traditionally, we can have all the control planes and the nodes as multiple processes in a single machine in the form of background process and things like that, but it gets difficult, and that is where we also have Minikube coming into our rescue if you're working with if you do not have any access to any servers and things like that, where everything is like a process. That's what the Minikube does. Minikube also has the Docker pre-installed inside it, and there are various kinds of tools for working with the Kubernetes, and the command line for kubectl is the command line tool. It is the most powerful tool or most commonly used tool across anywhere. Internally, the kubectl is interacting with the API server. API server takes all the requests in the form of the JSON or the YAML data and executes the REST based URLs and returns the data about the workers or maybe about the from the master. So it is facilitating the interaction or the communication between the master and the outside world, and the outside world and within the cluster is one way to think of it. Okay, kubectl, it enables pods to run on the node. So when we say pods indirectly, they're nothing but the containers with a layer on top of them. We can create the pods, we can create this services, destroy the pods, and other things. UI and API are two other ways of interacting with the Kubernetes, but CLI is the most powerful tool to interact with the Kubernetes. We can use the kubectl in both single node scenario and also multi-node production scenario. And Minikube, again, I don't think we need this one, but me put this here because we already are looking into the AWS. I'll go into a slightly advanced scenario and see what we have. Okay, so here is a brief look at a simple project. how we would look like, and we'll try to get a feel of some of the configuration files. Rahul, can you see my screen? I have the project overview screen here.
Yes, yes.
So here is an example of a high-level design of a web application under MongoDB, which is a NoSQL database. The web application runs in a container in Docker, and it's in a separate pod, and MongoDB is a database which is installed and configured in a separate pod. The web application communicates with the MongoDB using the service, and secret and configuration maps are a couple of configuration files we need to have an idea generally when we are working with the Kubernetes. The traditional, the fashion is most of the time the Kubernetes, the guys who are into the Kubernetes are generally looking at the YAML files. They're configuring the YAML files just like in Ansible, and they are setting up the infrastructure and taking care of the infrastructure rather than writing the code. So without really going to the details of writing the code, just by manipulating the YAML files, there are a lot of high-level design and high-level architectural infrastructural stuff which can be done using Kubernetes. So that is why it is a good idea to have a good idea about the YAML files, guys. Okay, so we have a database, we have a web application, and we have a few configuration files, config map secret.yaml, and we also need to take care of the database and the username and password credentials. We also need an external service for external access, so that if our web app is exposed to the external world, we need a web address to access it. Ideally, the Kubernetes documentation provides a templates for all the configuration files. We'll look at a few of them from a discipline standpoint. So config map secret, and then we have a deployment and a service files for the MongoDB or for the database, and another deployment and a service.yaml for the web application. So at a high level design, we have two services, one config map, which stores the configuration information, which is slightly less confidential. Secret is the configuration config file, which stores very confidential information like username, password, access tokens, and things like that, guys. Okay. So when the users access the node IP 30,100, the request is being sent to the web app, the service can pick up, and it can also go ahead and do the load balancing internally. It will also communicate with another service which is exposed as for the MongoDB, and that can also be internally load balanced at a Kubernetes level or a layer, guys. Okay. So ideally, if you look at a Mongo config.yaml, again, here is an example which is already given. This is the one we can get it to get a quick idea. And some of the important parts contained in the kind, metadata, and the data. Kind is where we can specify whether it's a config map and telling the Kubernetes, hey, this is configuration information. It can also be a service or a deployment. Metadata, an arbitrary name. You can give whatever name you want. Data contents is the actual key value pairs. This is where we specify Mongo URL. So this will be the service name of the MongoDB. So in other words, this Mongo config.yaml is the name of the YAML file, and kind is config map. Here we're giving the so the important thing is we are specifying it's a config map file is what it is. Then Mongo URL. So config map, we are specifying the MongoDB endpoint. The DB endpoint is where your server URL, server address, and things like IP address and things like that are specified. Secret again is where we specify the username and the password. MongoDB application database is generally exposed only within the internal service, and web app is generally exposed using the external service. We'll try to discuss about that. Another template for secret, here is a quick look. So there it is. If you look at the data, under the data we have, so notice the kind is secret, metadata name, you can give any name, type is opaque, opaque is the default, data is username and password, notice they are encrypted. And this is the kind of information which is slightly confidential. If you look down a little bit, we say kubectl apply -f mysecret.yaml. So these are the kube commands that we keep running to tell Kubernetes, hey, here is this, here is the location of the secret, here is the location of the config, and so on. And there it is. Kind is the secret. Metadata name can be any name. Type is opaque default. And data is where we are actually saving the username and the password. For example, if we have something like a Mongo user and a Mongo password, what we can do is we can pipe it to base64 and it will generate a base64 string, which is kind of like at a simplistic level, we can say it's an encrypted string. That is the username and the password we can save in our secret .yaml file, guys. Okay. So again, reference secret. So ideally in a config map, we don't really refer to the username and password directly. We actually use the reference secret from this secret file, and we don't give access to the secret file to everybody, is what it is. So here it is. If you come back to the kind config map, we're creating another one. This is okay. We'll see how to refer to the username and password in a moment. So here is the deployment and service in one file because they are together. In other words, again, back to Kubernetes documentation, ideally we can copy, paste it here. And notice the kind on the top is, and the second line is deployment. Then we have labels. Labels app is Nginx, means we are, Nginx is a web application. Imagine for a moment you got from your development team. That could be any other application. Just like we expect engines to work. Nginx is like a lightweight web server to work. We would expect from within an application, the development team would be taking care, but how you deploy at a high level, at an infrastructure level, can be manipulated and dealt at our level, guys. Okay. So replicas is 3, which means we are telling, hey, we want 3 pods to be running. So spec is the specification. Match labels, again, that is, we're giving the name of the application. Again, on a need to basis, we can look at some of the tags and the child element names and so on. So there is container port 18, deployment specific specification. So we're referring this as deployment specific specification. And image is Nginx 1.14.2. So ideally, if we run or apply this YAML, Kubernetes will download that Nginx from Docker, from hub.docker for that version 1.14.2. We can also give it as latest. It can also download the latest one, guys. Okay. So coming back here, a couple of important things. Kind is deployment. So in other words, we need to explicitly kind of keep in mind and have an idea that there is one called config map. Generally in a Kubernetes world, these are the terms which are going to be floating around and thrown at you. They'll be referring to config map secret, which we just discussed. And here is the third one, which is a kind, which is a deployment file, where we are giving the deployment information in the metadata is what it is. So the blueprint for the pods, this is acting like a blueprint for the pods, how many pods you need, what you have inside the pod and things like that. What you have inside the pod is the app part of it, which is the Nginx, and how many you need 3 pods. So if 3 out of 3 of them, if one goes down, the service will automatically try to bring this up. That is how it works, guys. Okay. Rahul, are you with me, buddy? Is that making sense?
Yes.
Okay. Humera, Kajal, everybody else doing okay, guys? I'm just referring to Rahul, just keeping him as a point of contact. Hope others are doing okay. Okay. So a little bit of configuration stuff, just bear with me, and we'll get into a little bit of practicals, and we'll look at a slightly real world application in a moment. Okay, there are containers, which image is we are telling, hey, and which port we are telling. The images the Kubernetes will download from the Docker, and we can push it and pull it, and we'll see that in a moment, guys. So ideally, imagine we were looking at a scenario for something like MongoDB. Here is Mongo. If you were to go to hub.docker.com, and there is the Mongo, you can just say Docker pull Mongo in a Docker world, but ideally we would figure out. Notice here there is 5.0. Maybe it's a stable version. We can just go ahead and specify the 5.0. It's up to you. You can get the latest one, or you can also get a specific version based on the your development team and so on. So there is the MongoDB. We're giving the right names, and generally runs on 27017 create pods port. So then we have the labels. You can give any component, any K8 component as label. Labels are the key value pairs that are attached to the K8 resources. In other words, labels are nothing but the keys and values. So label is a key for which it has again another key and a value called app and Nginx. They're like the identifiers which should be meaningful and relevant to users so that others can easily understand. So release, environment, and things like that are some examples of those things, guys. Okay. So labels do not provide uniqueness. Example, all pod replicas will have the same label. In other words, we want 3 pods to be running for a particular application. In such case, all the 3 pods will have the same name, is something to be kept in mind. It's not a big deal, but just to be kept in mind. Okay, identify. So label selectors, they identify, they are like the identifiers. They match all the parts. The app : engines is how we will see them in a moment. And there it is. Replicas is 3 means we want 3 pods. We've given the app. This is for the Mongo or database, and engines deployment. So we're just changing these things here. So replicas, how many pods you want to create, again, is what it really refers to. You can have multiple YAML configurations within one file. So the entire configuration can be copied, pasted below, and with slight changes, we can deploy we can have both the deployments of the web application and the database in one file, is what it really means. The next configuration file is the service file. Here's a quick example in the documentation. And notice a few important things. Kind is service. We are actually copying and pasting it in the same file below. And name is, you can give any name. Selector, select pods to forward the request to. So when a service gets a request, it is indirectly forwarding it to pod. The pod will actually forward it to the container internally and try to execute the request and get back with the response. So that is what is the selector app. And ports, again, target port, what is the internal port, what is the external port that you'd like to expose, and things like that are the ports and the target ports. So here we have some. For Mongo service, the port is 8080. We get the request from there. Internally, it is forwarding it to a different port, a target port, and that is internally forwarding it to the container port. Is how it works, guys. Okay, so that is the deployment and the service part. And web app deployment, again, we have just looked at the MongoDB. Now here is, if you just copy paste the same file, modify everything in a similar way to web app, and there it is, the service part of it. On the top is the deployment. Let's see, here is a kind is deployment. If you're observing, if you come down, kind is service. So we're putting both the deployment and the service in one YAML file. You can have multiple of them in one YAML file, just for some productivity and time saving and things like that. So here, the kind is service, the name is Mongo service. You can give any name, and selector is Mongo. I think we're just changing it to web app. And if we go a little bit down, Node.js app listens to the port 3000. So in case we have a Node.js, we can configure it to port 3000. There's a port and a target port, again, for the web application. Okay, and the pass. So this is where a quick look at the secret Mongo URL secret. We will need the username and the password. So we will generate a new user and user's password. Again, 27017 is the port on which the MongoDB runs. Here is the username and password example. We can use initdb root, initdb password as a couple of examples of the username. But the thing is, we need to pass it to these things. So that's where, notice we're giving env is becoming the key, which has a name and a value. And secret keyref is Mongo secret and Mongo user. Mongo secret and Mongo user are going to be picked up from the secret file, which we just secret.yaml file, and they're going to be applied, or they're going to be given to this for communication between the services. So secret keyref is how we are using. It is sitting inside the environment element or the tag or the component, is something to be kept in mind, guys. Okay, none of these things we need to buy hard or anything, but we just need to have a high level idea is what it is. That's how we establish the communication. Okay, passing the config. Okay, so database endpoint, database username, password. Again, a couple of them, the last two are coming from the secret. The endpoint is coming from the config map, and the web application needs to know these information, and both of them, both the web app and the Mongo are accessing the secret, whereas web app is only accessing the config map because it needs to know the endpoint. Generally, the database, you don't mind if others know about it, the IP address and the URL and things like that. Whereas the username and the password is much more confidential. You wouldn't like to give it up. That's why only web app is accessing the config map and not the Mongo, it doesn't require because it itself is the database, guys. Okay, web app expects these things. So if you come here, so again, that is in the secret key ref the MongoDB is using. So we create secret or config map just once and reference as often as you need. So again, no matter how many deployment files we are using, for different applications, we use different deployment files and different services and things like that. All of them may use one database or multiple databases. All the information can be plugged into the secret files, guys. So secret key ref is your something to be kept in mind. And user password, username, name user password, notice how they are given here. And that is a Mongo URL, Mongo-service. Ideally, that would be an IP address or maybe a the host name would be the endpoint and things like that. Okay. So, and then the last step is configuring the external service. So once we have the web app and the MongoDB deployed, what we need is we need to expose it, its IP to the outside world. And that is what is external IP. And not only do we have an external IP, generally we don't give the IP, you give some kind of fancy name, node.something, node.com, node.js and things like that. So that would be your external URL. I think external service, let's see, mongo.channel. So let's see. So there is, by default, there is something called cluster IP, node port, and then there is something called load balancer. An external service can run as a cluster IP, which is nothing but a single IP for all the entire cluster, which is internally accessible. It's an internal service. Node port is generally slightly less secure. It exposes the service on each node's IP at the static port must be between. So again, it is slightly less secure. Generally in a production environment, we don't use node port, but we would use something like an ingress. And we'll try to talk a little bit about that. So for node port, we can use any of these numbers port numbers between 30,000 to 32,700 and so on. So here we're using 30,100. And once we give that, that is going to be acting as a port for the external world to access it. Okay. Minikube, I don't think we need to worry about the Minikube, but let's get it. Today, we'll try to deploy a simple example of Python application and try to get a feel of it. So Rahul, can you bring up your screen, please?
Yes.
Copy this one. Minimize this one. And just make this. Paste it here. So from okay. Set. Okay, so let's see where we are. And today, what we'll do is we'll deploy simple Python application, and we'll try to get a feel of some of the YAML files and so on. So.py. Okay. Go ahead and log into. Okay. Master. Yeah. We'll start with the project. Once you log in. Okay, create a just see in which directory you are. You should be in the home directory.
Sorry, what I should type?
Can you do a PWD? Okay. Create a directory called proj1. Make the dir. And inside that, proj1. Project one, yeah. Project one, sorry. Okay. And go to the directory and then create another directory called source. Okay. Now let's say I don't think we need the requirements. Create a file called vi-server.py. And I will give you the code. So I copy this one. Server.py, yes. Paste this code inside that. This is like a simple Python Flask application. Okay. Save it and quit it. And give just verify the permissions on that. See if there are execute permissions. Okay. Go ahead and grant the execute permissions, please. Verify it. So okay, good one there. And let's say go back to the parent directory. And create a Docker file, capital D Docker file, just one word, vi Docker file. Yeah, and paste these things into that. So let me copy this one. Copy this. Okay. And scroll up, please. Okay, so from Python 3.7 as base. So in other words, Python 3.7 is a lightweight installation of Python is what we are downloading here. Run make directory workers. So if you remember, all the left-hand side ones are referred as instructions in capitals. On the right-hand side are referred as arguments. The arguments are going to be executed by the Docker container. So it's going to create a work directory. Then we are going into work means we are seeding into the work directory. And I don't think we need source requirement.txt. Okay, that's okay. We can you can comment the line where it says copy requirements. Comment, just put a hash. Okay, run pip install Flask. So Flask is a REST-based package, also used for building UIs and things like that in Python, and that is what it will be installing. Then it is copying whatever is in the source, and right now we have only one file, hello.py. Server.py. Which is going to be copied into this directory. Then environment Flask app is like an environment variable where we're giving the server.py. That is going to be the entry point into our application. And start new image. Okay, I don't think we need the next few lines, but if you scroll down under start new image production, the debugger is not really needed, but under production from base as prod, command Flask run means we are going to be exposing the port 5000 and we are going to be using it and running for accessing this particular file using Flask. So command Flask run is going to be executed when this container begins. It is entry point and it is going to run on the port 5000. We should be able to access it using the 5000 port. If you recall briefly, these are the commands and the things that we discussed earlier in the earlier days, Rahul. Okay, buddy?
Yes.
Scroll down, please. Let's see if there's anything else.
No, sir.
Okay, you can write and quit. And okay, so let's see. Okay, now what we need to do is we need to get into, by any chance, do you have an account on hub.docker.com? Can you open up hub.docker.com? I need you to create a temporary address on hub.docker.com, and you can stop sharing while you're entering your usernames and password. Just create some temporary. You can stop sharing it for a moment. and just create a temporary account on hub.docker.com. Pardon me. You don't need to put a, you can just go for a personal only, right? You didn't go for, okay, you're already logged in. Okay.
Yes.
Now that you're logged in, go to click on repositories. You don't have any repository here. And let me see. So you have signed in. Okay. Have you verified your email address? If you go click on Rahul Gupta 1234, don't do not like that. Wait a moment. Click on that. Your username is there on the right hand side top, right? Click on that, and let's say I think you need to say go to account settings, notifications, unverified. You need to verify it somehow. There is unverified. Click. Put your cursor near unverified. On the right hand side, the email icon. Okay, now stop sharing, open up your Gmail, click on that link that they send you, that will make sure it is verified. And then
Yeah, I have verified using my mobile phone.
Oh, you already verified, huh?
Now, I have verified just.
Oh, okay, very good. Good. Okay, that's all. So for us to be able to push our code, we need to be able to verify that one. That's a requirement. Okay. So now come back here. And before we push it, let's go ahead and create a, back to your terminal, create a docker-compose.yaml file. Okay, so let's see. I'm going to send you the YAML content. Paste this one, and you need to change your username. So, chat, pasting it here. Okay, copy this one, and container name is going to be Python image. It's going to be and in image, instead of SciGraph, change it to Rahul Gupta 1234. Yeah, the left hand side. Write and quit. and cat it. Oh, and so there it is, services Python. If you recall, Docker Compose, we're going to be using it to bring up a group, build an image rather than executing the steps individually. We're going to be running a group of steps at one time. So here our container name, we are giving it as Python. The image is Rahul Gupta. That is where the image is going to be pushed to by the Kubernetes, and ports are nothing but the internal and the external port that we are going to be accessing this application. So what we'll do before that is go ahead and say sudo space docker compose, docker-compose build Python. Docker-compose space build space Python. Okay, run it now. Sudo command not, docker compose command not found, sorry. Install docker compose, please. You can do a sudo apt install docker compose, sudo apt install space docker-compose. Yes.
So currently we are creating image for this application, right?
Yes.
And then we are pushing it to hub, and then we will use that in a Kubernetes. Okay.
Kubernetes will use that from Docker.
Okay.
Okay, so let's see, let's run it. Instead of build, say up Python. Warning is okay, error is not okay. In build context, source file does not exist. Just to ls. Oh, and you created, okay. Under project one, you came back to, you created the Docker file and the Docker Compose, right? Move the Docker file and the Docker Compose to project one. for Docker file. So, okay, go to project 1, CD, list it.
Should I change this name also? SRC.
Yeah. And put the server.py inside that one. Move this server.py. Okay, now build again one more time. Perform the Docker Compose build. Do the Docker Compose build first.
This command.
So the first few steps using cache. These are the layers it has already downloaded and plugged them into the cache. If it needs to do these things again, it will run much faster. Okay, successfully tagged is good one. Now up and run it. Okay, so now we need to access this port. So go ahead and give the security, open up the 5000 port. And just refresh it here in your repository. If you refresh, you should see a.
So this container is running on the worker node.
Yes.
Or it is on the master.
No. This is right now on the master.
Okay.
There are no repositories. I think. Let me see. Maybe we need to manually push it. Credentials. I think. Let's see. Strange. Okay, I thought it should be there. We'll come back and check it, but go ahead and first get the 5000 port. Okay, now find out the public IP. Now bring up new tab, access it, port 5000. Okay, that is hello world, and that is what we are able to bring up from the container, or more precisely from the application. We may ideally do whatever complex logic or whatever is requirement based on our own application and the requirements, but fundamentally we are able to access the application. Catching the point?
Yes.
Okay.
Yes.
Go back. You can stop the terminal. We verified we are able to run it locally. And let's see. Okay, so what we know, okay, now this is where we're going to be pushing it. We'll say sudo docker login. And before you do that, just take a short 5-minute break. Sorry about that, Rahul.
Okay. Okay.
Thank you. I'm back, Rahul.
Yes, sir.
Okay. Go ahead and log into Docker. Say sudo docker login. Enter your username and password. Whatever your password is will be stored. Okay. Okay, looks good. Then go ahead and let's say build Python. Okay, let's say sudo docker compose push Python. Sudo docker compose one word hyphen compose space push Python. So that is the name of the image. Enter. Okay, now go back to your browser, refresh that. Okay, there it is. So that is the image. Now let's say we'll run a few cube commands here. kubectl get nodes. I think yesterday we have brought up the kubectl, right? kubectl get nodes. Can you just go back to the browser and verify their nodes? Oh, there you go. Okay, so we have one master and two worker nodes here. And let's say we'll go ahead and create a directory called Kubernetes.
Inside this directory project.
Yes. Kubernetes, yeah. Then go into the directory and create a directory called deployment.
What is the name?
Deployments. Okay, let's go ahead and create a deployment.yaml, vi deployment.yaml.
After going to this directory, deployment.
Go into the directory. Deployment.yaml, YAML, use
YAML.
Both of them are good, both of them are same, but we'll follow practice. Yeah, enter. And let me send you the config information. Okay, I'm gonna copy this one, pasting it in the chat window.
Yes.
Wait. Pardon me. And write and quit it and cat it. And if you go up, so this is going to be the kind is deployment. For deployment apps /v1, that is how that's more of a format that you need to give. Metadata name, you can give anything. We're calling it as example deploy, labels app, any name you can give. We're going to call this as example app. Then spec, this is the specification part, match labels, exam lab, that is the name we're going to be using again. We want 2 replicas, we have 2 workers. And the strategy, rolling update is where at the times of upgrades and updates, we are going to have a limited set of users upgrade and gradually increase the total number of upgrades to the rest of the servers. So you first deploy your latest one to, imagine you have 10 servers, you deploy to 1 or 2 servers, and gradually the remaining servers will run the old version. And after a few minutes, maybe a few period of time, you will go ahead and upgrade the remaining servers. That is generally referred as rolling update. Maximum surge, maximum available. These are again a few specific attributes. We'll see if we can revisit them. I don't really, I know I do have an idea, but I'll try to explain you a bit more. And then we have the template. So example app again is the name of the application. Then the containers, here's the container specification. So on the top, so let's see what we have. Example app, okay. I think you will need to change that to Rahul Gupta.
Yes.
So, and so we'll change that in one moment. Image pull policy, we are always going to, whenever we're going to run this command, Docker Compose or anything, we're going to be pulling it. We're asking Kubernetes to pull the latest image from the Docker. And 5000 is the port we have just exposed. And resources requests. Request says we are saying we want to use 64 meg RAM and 50 M is roughly 50% of the CPUs. The limits is the upper limit. If it goes above 256, if our application uses more than 256 MB or maybe CPU 500, I think if it uses more of CPU, these are the upper limits where the application will be brought down and will be restarted. So limits is really upper limits. Requests is really the what we want our memory and CPU to be used or consumed. So go ahead and modify that.
So yeah. So this is we can scale vertically by specifying this limit.
Very good. That's vertical scaling. True.
Yeah, and sir, how we perform this update? Like we update this image in Docker Hub, it will means how we perform this update.
Well, that is how you run it. We are going to run this file now. When you run that file, that's how the latest one will be applied. This
Okay.
will start going to effect.
Okay.
Okay. So
Yeah.
look at the image.
So do we have version there or it is just constant?
No, that's it. Have you given the same name, Python 1.1.2 last time?
No, only Python.
Then I think you can change that to Python.
There is one tag by default maybe.
Add the Docker compose.yaml. Look at your Docker compose.yaml.
Okay.
I think that is in project 1. Project 1. Now, Docker compose.
Yeah. So this will work. Okay.
Rahul, can you?
Hello? Hello? Sir, you are not audible.
How about now, Rahul?
Yeah, now audible.
Okay, sorry about that. Rahul, can you share your phone number with me? Because there are some, just in case there's a power cut and so things like that. I'll just, can you put your message, your contact number, just in case I need to get in touch with you?
Okay.
To log in. They said there are some power fluctuations going on at mine. Thank you, Rahul.
Yeah.
Copy that one just in case I need to reach you. Okay. So let's say, so since you have Python 1.2.0, you have given in the compose because we have first release of the image. Let's go ahead and use the same thing, Rahul.
Yeah.
I need to get back into, let's see. Are you waiting for something, Rahul?
Huh?
Are you waiting for something?
Sir, we need to run that container in Kubernetes, right? So I don't know.
You need to run, you need to make the change, right? Earlier, I think you just put
I did already.
Okay, can you cat it?
Yeah.
Okay, looks good. So now we'll try to run this one, say kubectl apply -f deployment.yaml. Yeah. So now say kubectl get deploy. So that is a deployment process is what we say. Next say try to get, so up to date is 2, 0 to ready is 2, available is 0, age is 14 seconds. So it's still taking time. Say kubectl get pods. And there are 2 pods running. Status is container creating. Okay. I think if you give a little bit of time,
Yes.
They will be able to see status updated. And let's see. So this is the pods which are created, and we have created the deployment. Deployment is also a unit of deployment. The deployment.yaml is a unit of deployment, which is internally having the pod. The pod is internally having the container, is what we say. So generally, we don't say we are directly creating the pods. We say we generally create the deployments as something to be kept in mind. And now, once we create the deployment, we also need to go ahead and create the service to expose this one. So just one more time, bring up the get pods. Continuing reading. Okay, that's okay. We'll see if we can refresh that a few minutes later. Go back to the parent directory, one level higher, where you go to the Kubernetes. Yeah. Now let's create a directory called services. And go into that directory. And let's create a service.yaml. and I'll send you the config file. So I copy this one. Here we go. Paste this one. So AVI version is V1. This is the first version. This is the first service. So we're going to call it is of kind service. So Kubernetes understands the language of service and deployment. And metadata, you can give any name. We're saying type is load balancer. There are two other types. One is node group, another one is an ingress. We'll briefly talk about them in the coming up days. Load balancer is used for load balancing. This is a load balancer at a Kubernetes level. No, the Kubernetes itself is doing the load balancing at a pod or a deployment level, and it will take care of the load balancing if should the requirements grow, should the thresholds be met, and things like that. Apart from that, on top of it, the AWS load balancing can also be provided both from an internal and external standpoint, is what it is. But this is at a Kubernetes level also we're able to do the load balancing, is what it requires.
Okay.
Now the next thing is selector app. That is nothing but the app here. We're kind of saying, hey, so this is the app that you need to be, your pods are belonging to. TCP port 80 and 5000 again. Internal and external ports is what they are. We should be able to access them. So go ahead and write and quit it. Then say kubectl apply -f and say service.yaml. Created. Okay. Say kubectl get service. SVC, sorry. SVC. V for Victor, C for Charlie, C for cat. Yeah. And so notice example service load balancer. So this is acting as load balancer. Now we have cluster IP. Cluster IP is only internal. The external IP is pending. Can you just say kubectl space IP? IP. No. IP. Enter. Let's say. Okay. Go back to the Amazon console. Copy the public IP.
Of worker.
Master.
Okay, master.
And I think we are looking at the port 5000. Give it a moment. Let's say. Try the port 80, please. Back to the terminal. External IP is working in. I think the internal IP will not work, but just try to use the internal IP and give the port 80.
This one?
Yeah. Okay, back to terminal.
Still showing pending.
Okay, Rahul, sorry about that. I'm having a little power cut issues at my end. There is some work going on outside, so we got a message saying that there are going to be some power cuts today. So just bear with me.
Sir, the containers are also not ready. They are still showing status container created.
Okay. One moment, please. Can you make me the host, Rahul?
It is host right now.
Hmm. Sorry.
Right now, Aniket is the host, so we can make it.
Okay. One moment, please. Okay, can you try to run this command, Rahul? Sent it in the chat window. What's that? Scroll up, please. Okay, so let's say pod example deploy successfully assigned scaled up replica. Okay, that's where it's setting up the replica to 2. It created the pod, successfully assigned default. No, I don't think we need the ones below. Failed to create RPC error. Flannel. Sandbox change. I think these are from the yesterday ones. Scroll up a little bit, please. Okay. Just say get pods again. Copy the pod name, maybe the first one, and let's say kubectl describe pod and paste the name. So this is giving complete information on pod name, default node start time, labels annotations IP, control by replica set, Python container image, reason is container creating. So it looks like it is just stuck there. Projected token extraction cube root. Now scroll down, please. This is page from message morning. Failed to set up sandbox. What? Failed to create sandbox. Okay, looks like subnet flannel directory. I think yesterday we set up a flannel, which will we ran a flannel related thing.
Yes.
With plugin. I'm just thinking if you need to rerun that. These are probably coming. Strange. These are coming part of the describe of the pod.
Yes, all from here to will describe pod, and from here till all these are the part of that.
Okay. Let's try to see if we can restart this one. Let's see. Let's copy this and paste this one. Try restarting the kubelet service. I just pasted it. One more time. Could you try restarting the kubelet service? See, there you go. Authenticating as Ubuntu. Required to restart. I think maybe you should have done a sudo. Oh, okay. Service restart. Okay. Let's give it a few seconds and we'll try to check the pods and the nodes again.
Okay.
Let's see. Try running all the namespaces like this. Okay, container creating and scroll up, please. Few of them still sitting in container creating status. Copy the, do a get pods again. Let's copy the name of it. Copy the first name. And let's say back here, let's delete this one. Pod hyphen namespace. Let's say copy this one. Okay. After the namespace, put a space and give the pod name. I've sent you the delete pod.
Should I remove this namespace or
Error from the server. Ports not found. So you deleted it, right? Yeah, do a get ports again. So let's see, that's the one you deleted, not found. I think it restarted it, is what is, no, that says 22 minutes back.
So it is also having this namespace in the command.
1 second. Delete port -n namespace example deploy. Delete port, remove the -n namespace and just give the port name. Yeah. Okay, get ports. 5 seconds.
Yeah, created.
Recreating it immediately. And that's still okay. We need to say 1 moment. I know this doesn't need the config map and the secret unless we really need it. It's not mandatory. But bear with me for 1 second. Okay. One more time, get ports, please. Still in container, and let's say get nodes. Nodes is ready, which is good. Okay. Service. Can you do a get service, please? So it looks like some of them are saying the external IP is pending state. That is why it is not able to communicate with the worker. And I think what is happening is it is unable to deploy the container or because of the external IP is what somebody seems to be saying. But let me do this, Rahul. Let me look at this one a little bit today, and let me see if I can dig into this one. I did not face this issue a few days back, and when I was trying it out, even yesterday also I came across some issue with the AWS stuff. I think T2.micros were also working, but it looks like the AWS policy has changed to T2.medium. This is one of the problems. So every week there are some changes are happening at their end, and they impact some of these scenarios. So what I will do is, my next scenario is also in continuation with this one, but until I think I take care of this one, I will not be able to move to the next one. So let me look into this one and try to get back to you. And so what I'll do is, for today also, I don't have anything else other than the next one. I'll probably continue tomorrow and go from here, Rahul. Okay?
Okay.
Sorry about that. And I will continue the journey tomorrow and go from here, guys. With that,
Okay.
I'll see you guys. Take care, stay safe, and keep learning, guys. Sorry about that again. Signing off for today.
Thank you.
Thank you, guys.